Bismillahirrahmanirrahim. Today we are going to start second session of our lecture week number 9. In first session we have discussed something related to deadlock avoidance, and we have discussed safe state and unsafe state, and we have seen if we are in safe state then there will be no deadlock, but if we are in unsafe state then there are chances of deadlock. Now we have some algorithms, that deadlock avoidance algorithms. Now it depends on the number of instances of a resource type. So to use the algorithm, if we have a single instance of a resource type, then we will use resource allocation graph scheme, which we discussed in first session of lecture week number 9. And another is, if we have multiple instances, then we will use Banker's algorithm. Okay, so in resource allocation graph we have seen there will be a claim edge, and this claim edge will be converted into the request edge, and then request edge will be converted into the assignment edge, and then when that process finishes work, then again this assignment edge will be converted into the claim edge. But whenever we are going to convert any request edge to assignment edge, we need to ensure that there will be a no cycle. If there is becoming the cycle, then we will not convert any request edge to assignment edge. Then we have seen one example that which shows the sequence, safe sequence. Now today we will start our Banker's algorithm. So this name, if you see the name of this algorithm, this name is chosen because this algorithm could be used in banking system. And why to use in banking system? Because to ensure that bank never allocate its available cash in such a way that it could no longer satisfy the need of its all customer. You have seen whenever we are going to the ATM machine and there is a limit, it does not matter how much money I have in my account, but I can withdraw a limited amount of money from ATM, because there are many customers of bank, and the bank have to satisfy all his customer. So that's why they put some limitation. They are not allocating that money or cash in a way that it did not satisfy the need of all the customer. So in Banker algorithm, the technique is when a new process enter into the system, whenever the process will enter, he must declare the maximum number of instances of each resource type that it may need. He must declare that I need how much instance of a resource, 2 instance, 3 instance, or how many resources I need. So also whenever the process will declare his number of instance, that number may not exceed the total number of resources in the system, because sometimes it is possible that we have only 10 resources and the request process is requesting for 11, 12. Okay, so need to ensure that the request or what he is declaring must be less than or equal to the total number of resources available. When a user requests a set of resources, the system must determine whether the allocation of these resources, the system is in safe state, because we know that we have discussed in the first session of our today's lecture that if our system will be in the safe state, then there will be no deadlock. But system will be in safe state, then there are chances of deadlock. So then system, it will check that whether the allocation of the resources in the system is in safe state or not. If it will, the resources are allocated. If the checking, after checking the claim for requirement from the process, if there is no chances of unsafe state, then the resources will be allocated. Otherwise the process must wait until some other process release enough resources. So this is the Banker's algorithm. Now we will see some examples of banker's algorithm. That let's suppose in this example we have 5 processes P0, P1, P2, P3 and P4. But the number of resources, the resource type, 3 resource type A, B and C. So we have process, 5 process P0, P1, P2, P3 and 4 and resource type A, B and C. This can be any resource A, B, C. Now we know that the resource type A has 10 instances. So A, it consists of 10 instances, B consists of 5 instances and C has 7 instances. So this is the available total number of resources we have. Now this is the snapshot of the system at time t0 and this is the safe. Currently our system is in safe. If you see this, we have 3 main matrix. First one is allocation matrix and second matrix is max matrix, mean maximum, and third matrix is available matrix. Now if you see this one, we have 5 process P0, P1, P2, P3 and P4. So allocation mean that currently process have how much instance of the resource. Let's suppose P0, if you see this one, P0 has 0 instance of A, P0 have 1 instance of B, total B we have 5. For P0 it has 0 instance of C. In same way P1 have 2 instance of A, 0 instance of B and 0 instance of C. Mean currently this is allocated, already they have this instance. P2 it has 3 instance of A, 0 instance of B, 2 instance of C and so on P3 and P4. This is allocation currently they have. But this second matrix, it shows that maximum. What is P0? He need, if you see the corresponding value, that in this it is telling that P0 it need 7 instance of A. 7. He need 7 instance of A. He need 5 instance of B and need 3 instance of C. And now if you compare the allocation and maximum need for P0, P0 has 0 instance of A, but he need 7. Maximum need is 7. 0 currently he has. For B, resource type B, P0 need 5 total instance, but currently he has only 1. Okay. Same way P0, he has 0 instance of C, but he need 3. So in same way this is allocation and maximum. Now if you check P4, let's suppose P4 he need 4 instance of A and currently he has 0. P0 maximum he need 3 instance of B and currently he has 0, and for C he need maximum 3 and currently he has 2. Now available is, these resources are available after allocation. After this allocation still we have these number of resources in our system. So currently available A is 3, B is 3, C is 2. Now we need to calculate the need. What is need matrix? We need to calculate first. This is the first thing. We need to calculate the need matrix. What is the need of P0, P1, P2, P3 and P4. So how we can calculate? We have maximum they need this, and allocation is this. So we will subtract allocation from maximum, so we will get need matrix. Let's suppose for P0 he needs 7 instance of A, currently he holds 0, so 7 minus 0. In need matrix P0 need 7 instance of A, resource type A. So in B if you see, maximum he need 5, currently he hold 1, so 5 minus 1 it will be 4, and here 3 is maximum need and currently he is holding C 0, so he need 3. In same way, just we will subtract allocation from maximum, we will get need matrix. See here that for this data we have calculated need matrix, and you can easily 7 minus 0, this is 7, 5 minus 1 B, instance B, this is 4, 3 minus 0, it is 3. So max minus allocation. So allocation we will subtract from maximum, we will get the need matrix. So if we check for P3, in P3 maximum A instance he need 2 and currently allocated is also 2, so 2 minus 2 it will be 0. And for B, he need maximum 2 instance of resource type B, currently allocated, if you see here, 1, so 2 minus 1 he need 1 more. Here for C instance C, for P3 he need 2 instance of C, resource type C, currently he has 1, and 2 minus 1 it is 1. In this way easily you can calculate the need matrix by just subtracting the allocation from maximum. So we claim at this stage system currently in safe state. So we say if we have this sequence, if we follow this sequence, we execute P1 first, then P3, then P4, then P2, then P0, there will be no deadlock, because important thing is we need to find out the sequence, and that sequence must satisfy the safety criteria. If we are executing a process first and our system is going to deadlock, then we will not execute this, we will stop it. Okay, so according to, just we want to check for this data that is given to us, that if we execute P first, then P3, then P4, then P2, then P0, then our system will be in safe state or not. Okay, so according to this it is given P1 execute the first. Now this is the situation, this is need matrix, this is available, and maximum allocation need already it is given. Now we need to check first thing, that is we will execute P1 first and P1 make the request. So what is the request? 1, 2, 2. It means 1 instance of A, 2 instance of B, and 2 instance of C. See here, this is your need. 1, 2, 2 mean 1 instance of A, 2 instance of B, and 2 instance of C, because we are going to execute P1. Okay, so this is our request. Request of P1 is this one. So to decide that we execute this process P1, we need to check that request must be less than equal to the available. If request is less than equal to available, then we will execute. But if request is not less than available, then we will not execute the process, because maybe process will go into the deadlock. So this is request 1, 2, 2 mean 1 instance of A, 2 instance of B, and 2 instance of C. It must be less than equal to available. So what is available? Available is 3, 3, 2 mean 3 instance of B, A, 3 instance of B, and 2 instance of C. So we are checking here that 1, 2, 2 is less than equal to available. Available is 3, 3, 2. So here we can see A he need, so one by one we will check here. that we will compare this with this one. 1 is less than equal to 3, true. Then we will check second, B, instance B. 2 is less than equal to 3, true. We will check then number third, that 2 is less than equal to 2, true. If all these are true, then we will execute P1. If anyone have problem, this condition did not satisfy, then we will not execute this process. Okay. So whenever P1 is requesting 1, 2, 2, mean one instance of A, 2 instance of B and 2 instance of C. So here you can check less than equal to available. Now all the other process P0, P2, P3, P4, there will be no change because we are not changing anything in this process. Just change will be in P1 because we are executing only P1 here. Okay. So P1 allocation currently it was 2 instance of A. But whenever he requests one more instance of A, and if we will execute this, we will grant this resource, then this 1 will be added into the 2 and then it will become new state of allocation matrix. Sorry, this one it will be 3 instance of A resource. Same thing B, he requested 2, already he has 0 instance. So 0 plus 2, it means next it will be 2 instance of B also. Then he is requesting 2 instance of resource type C, and currently before it has 0 instance. So we will assign these resources. So we will add this into the allocation matrix. 0 plus 2, this will become 2. Okay. So first step, what is first step? You need to check this condition that request must be less than equal to available. If this condition is true, then you will execute the process, otherwise no. Okay. So after, now what is the next step? When the request is fulfilled in the sequence, he will finish his work, P1 will finish his work and he will release the resource. Also, if you check the available, because this is the available state of available resources, 3 instance of A, 3 instance of B and 2 instance of C. Now whenever we will fulfill the request of process P1, that is 1 instance of A, 2 instance of resource type B and 2 instance of resource type C, then of course these resources will be subtracted from available. So total A we have 2 and 1 we have given to P1. So what is remaining? 2 minus 1, it is 2. So P1 resource type B, total it was 3 and he requested 2, P1 requested 2. So we have given to him, and then 3 minus 2, remaining available B is 1. In same way C we have 2 and P1 requested 2 and 2 minus 2, now available is this one. Now this is the current state of our system, that allocation matrix is this, maximum matrix is this and available matrix is this. So major change you can see here is in allocation and in available for process P1. It did not disturb other process P0, P2, P3, P4, only because here we are executing P1, so it will be affected, remaining it will be as it is. Now what is next step? That P1 request fulfill, that is resources assigned to P1. Now this is the situation, but after that when the P1 will finish his work, because his request is fulfilled, of course he will finish his work and then he will release all the resources. After P1 will finish execution, it will release all the resources and it will add it to the available. Okay, so before, this is the snapshot, okay, from last slide. So available, it is A is 1, B is 1 and C is 0. Okay, now allocation matrix and available matrix after P1 finish execution. When P1 finish execution, then he will release all the resources, and those resources will be added to the system. Okay, so now the need of P1, if you check here, it is 0 0 0 because his request is fulfilled. Now he don't need any resource A, B or C. Now after finishing, you can check here that this P1, when he will finish execution, then if you check this one, that P1 allocation 0 0 0 mean he free all the resources, and all these resources will be added to the available. When there are three allocation, 3 is given to him, these 3 when he will release, it will add it to the A. So 3 plus 1, now available it become 4 instance of resource type A. When he will release 2 instance of B, it will be added to the B. So it will be 2 plus 1, now available we have 3 for B. Then for C, same way, he will release the resource type C, 2 instance, and it will be added to the C in available matrix. Now it will become 2. So this is now when the P1 will finish execution, this is the state. So successfully we have executed P1 and we have seen there is no problem, there is no any deadlock. Now we will go to the second process in the sequence and we will execute in the same way. So we will go back and we will check the sequence again. Which process? Yes, we have to execute the next process in the sequences, that is P3, and P1 it is done successfully, no problem. Now we will execute P3. Okay, so same method we will use. So this is our need matrix and this is our situation of our P3. So in P3, if you check here, P3 need 0 instance of A, 1 instance of B and 1 instance of C. Again we will check that request must be less than equal to available. If request is less than equal to available, then we will execute the process. Okay, so this is the here I will explain that request. What is request? 0 instance of A, 1 instance of B and 1 instance of C. This must be less than equal to available. So what is available? 4 instance of A, 3 instance of B and 2 instance of C. So we can, now we have to compare. 0 we will compare, 0 is A with A, B with B and C with C. So 0 is less than equal to 4, true. 1 is less than equal to 3, true. And 1 is less than equal to 2, C. It's true. So if this is true, then we will execute P3. Otherwise we will not execute P3. Now only P3 will be affected. So allocation matrix is 2 1 2. When we will fulfill the request, so we will add this here. So he requested 0 instance of A, so already he has 2 plus 0, it will be 2, no change. 1 he requested for B and we will add this into the B, so 1 plus 1, now he has 2. Same, C he requested 1 and already he has 1, so 1 plus 1, now he has 2. This is the new state of allocation matrix. Now we have given these resources 0 instance of A, 1 instance of B and 1 instance of C. Now these resources, this instance will be deleted from the available. So what is available? Available before we have 4 instance of A, and he requested 0 instance, so there will be no change. 4 minus 0, it is again 4. And then he requested 1 instance of B, we have available 3, so we have granted his request. Now 3 minus 1, now currently available we have 2. Same way C, we have 2 instance available, he requested 1, we have given to him, so 2 minus 1, currently we have 1 remaining. Now this is our last state of allocation matrix, maximum and available. Now again his request is fulfilled. What is next step? When now the P3, he will finish his work, and when he will finish his work, then he will give all the resources back to the system. Okay, when he will give all the resources back to the system, now the current state of the matrix allocation, and it will be like this. Now his request, because he requested the resources we have given, now his request or need is 0 0 0. He don't need any instance of A, B and C. Currently he has 2A, 2B and 2C. This is the current allocation. Now after P3 finish execution, it will release all the allocated resources and it will be added to the available. This is previous state. 4, he has instance of A, B, 2 and C, 1. Now he will release the resources and it will be added to the available. So he has 2 instance of A, it will be added into the 4 instance of A in available. So 2 plus 4, this will become 6. Now current status is that after finish P3 execution, available A resource we have 6, and here 2 is given him, and 2 plus 2 B, it has 4. Okay, now 2 C, it will be added to available. 2 plus 1, 3. And if you see here that compare this one P3, now the allocation becomes 0 0 0 at this state, because all the resources which are allocated to the P3 are given back to the system and it is added to the system, and that's why you can check here this become 0 0 0. Now we have seen that we have executed P3 successfully. Now we will go back to the sequence and we will check the which process we have to execute next. Yes, we have seen that we have executed the process P3 successfully. Now the next process that we have to start, which is P4. And what is our current status of our system? That allocation matrix and need matrix and available matrix, this is our current status. Now from here we have to execute the next process, which is P4. And we know that what is the requirement for P4? He need 4 instance of A, 3 instance of B and 1 instance of C. Now again we will check that request must be less than equal to available. Okay, so what is request? Request is 4, 3, 1, and what is available? 6, 4, 3 available. This is our available. Now if this condition true, then we will execute P4, otherwise we will not execute. But currently it shows that 4 is less than equal to 6, true. 3 is less than equal to 4, B instance, true. 1 is less than equal to 3, true. So it means we can execute this algorithm, this process P4. So same, you have to apply the same method to solve this problem. So this is the way that how we have to apply the banker's algorithm on the process and the number of resources. One thing, the very important thing is that condition, that request must be less than equal to the available. If request is less than equal to available, then we have to execute, otherwise we did not have to execute. Okay, now in our next session, third session of our this lecture, we will solve another example. Okay, it will take maybe 10-15 minutes, and we will see that how we can solve this. Okay, this is again we have to check the sequence satisfy the safety condition or not. Okay, so if you have any question, you can ask me through by email, or you can visit my office during office hours. See you in the third session of our lecture week number 9.